Hello and welcome to my presentation. I'll be talking about machine learning on the Google Cloud Platform. By definition, machine learning concerns itself with situations in which you can't specify simple rules to get the results that you want. So we typically deal with inputs and results as an example, and then the rules that are required for attaining the results from those inputs are derived using machine learning algorithms. Now, there are various reasons for utilizing machine learning. You could use machine learning to extract insights from your data. So there are times when a simple observation of the data doesn't tell you what exactly is going on. So things like anomaly detection, for example. You could also use machine learning for making inferences on tasks, as well as for even predicting potential future outcomes on your data. Now, the environment for machine learning is diverse. There are all sorts of practitioners when you look closely at the landscape. You've got a wide range from product managers on the one hand to machine learning engineers on the other hand, with lots of roles in between. And every single one of these roles has its own needs. So while you build a product, there are things that product managers need, and there are things that data analysts need. And we've got some of these things on the slide on the screen. Now, if you look at the previous slide, there really isn't a specific category for software engineers. And the truth is, software engineers aren't really interested in machine learning. What they want to do is just utilize the product. They're busy building things with rules inside of them. So if you think of software, what happens when I click a button? There's an event handler somewhere. I want to specify the event that gets handled. What happens when I use a camera and I take a photo? I want to take that photo and store it in a location somewhere, maybe get a URL for that image and store it in some reference like a database. It's really plain and simple, right? I don't want to have to look into that image to determine certain things. Is the image suitable for work, for instance? Is there nudity in the image? Is there violence in the image? As a software engineer, I'm not really interested in having to figure out the rules that will make me extract all of that insight from the image. So for software engineers at various levels, there are tools on the Google Cloud Platform that will let you just get your job done and not worry about the very nitty-gritty details of the machine learning. And one of those is MLKit. And MLKit is an SDK that is available for both Android and iOS. And it comes with a bunch of features, as you can see on the slides up. And basically, what it seeks to do is it will let any Android or iOS developer utilize that SDK and call functions the same way that they're used to calling functions for every other thing on the platform, but then they can get things done. So for example, if I need to find out whether there's a face in an image from a mobile device, then I can use MLKit and I can make use of the face detection for that. Or if I need to read text in an image, let's say on a billboard, for example, from a phone, I can still do that using text recognition. So that's what MLKit does. And it has a whole bunch of additional functions, things like language identification. So if there's text in the image, it's able to even tell you what language, within a limited range, of course. It's not all the languages in the world, but typically about 100 of those languages can be recognized. And you can get all the information about MLKit on the link up on the screen right now. Now, if you're not working on mobile, but you're working on web, you're able to call API endpoints. And GCP makes a certain number of APIs available for you to use. One example is the Cloud Vision API. And the Cloud Vision API, as the name implies, lets you work with images, and it will let you do a bunch of things, identify what objects are in those images, classify those images. So it will tell you, is this a cat? Is this a dog? Is there a cloud in there? Is there a car in there? And you're able to use this API to do things like visual product search. Again, you can detect text and detect faces within images. You're able to do content moderation. So if you think of a situation in which lots of images are uploaded to your platform, and you want to ensure that images that are not suitable for work don't make it through, prior to using the API, you might have had some other way of doing it that might not have been scalable. So for example, you might have people who have to sit down and look at every single image that is uploaded to decide whether or not to let that image through. With content moderation, you're able to get the probability that there's something in that image that isn't suitable for work. And as a result, you can strike that image out. And the Cloud Vision API is available at the link shown on the screen. And similar to the Cloud Vision, there's also a Cloud Video Intelligence API. And this simply applies to video content. And the link is up on the screen. Similarly, there's a Cloud Natural Language API, and this lets you deal with text content. And if you're familiar with the world of natural language processing, then you're going to be able to do things like entity extraction and parts of speech tagging. So if you come from a linguistic world, this will make sense in terms of being able to take text and decompose it into a number of components and then build your solution on top of that. And the Cloud Natural Language API is available at the URL up on the screen right now. And there's also a Cloud Speech API, and this deals with sound or speech, as the name implies. So you're able to do text to speech, which is take something that is written and convert it into sound files, or do speech to text, which is take something that is recorded and convert it into text so that you can do something with it. And this has language identification for 120 languages. And you're able to work with both streaming audio and recorded audio. The difference is that with recorded audio, you need to upload that recording to a cloud storage bucket. And for text to speech, you're able to get your recordings in about 30 languages and in up to 180 different voices. Now, if you're more interested in conversational user interfaces, that's what we tend to call chatbots, then there's Dialogflow that you can make use of. And Dialogflow will let you accept input using both voice and text. So if you think of your Google Assistant, you're able to type, but you're also able to speak. So you can turn on the microphone and speak. And there's a visual flow builder. So you're able to visually design your application. And at the very end, you're able to connect to APIs that will do the actual implementation of what you want. So when you think of chatbots, it's someone communicating, conversing, and asking for something. If you're building a financial application, the person could be asking for their account balance. They could be asking to make a transfer. They could be asking to make a purchase, right? So while Dialogflow will handle all of that logic of trying to figure out what it is that the person wants, which is called an intent, you're going to need to have an API endpoint that will implement that intent at the end of the day. And Dialogflow makes all of that possible. And It supports omni-channel implementation. What that means is when you build your app with Dialogflow, you're able to expose it to a number of platforms. And those platforms include, Amazon Alexa, Google Assistant, Facebook Messenger. You can expose it to a web app if you want. And Dialogflow is available at the link on the screen. Now, we also have what we call data enthusiasts. So you're not strictly within one of those buckets of, say, ML engineer or data scientist or data analyst, but you have a pretty strong understanding of the machine learning landscape, and you would like to build a custom product that isn't available using one of the APIs. So the APIs that we've looked at so far are trained on general purpose data, very large corpus. But what you want to do is leverage something like transfer learning to take one of those models and to make it work with your very specific use case. And what that is a product called AutoML. So AutoML will take your data, it will search through a number of pre-trained machine learning models, and then it will carry out a bunch of activity, hyperparameter tuning, neural architecture search, and things like that. And it will do that for a period of time. And when it has exhausted the time limit, it will then return the best performing model that it was able to find within that time frame. And AutoML is available for things like translation, computer vision, video intelligence, natural language, and structured data, which we call tables. Now, if you think of translation, there's the general purpose translation that you've seen that you can do with natural language. But then there's special purpose translation. Special purpose translation could just be that in a particular context, maybe in an academic setting or in a certain professional setting, the translation doesn't work the way it works in the general communication space. So for that reason, you'll need to bring your own data that shows AutoML examples of translations that have been done in that specific domain, and then it will be able to give you a model that will handle translations. Now, the workflow for AutoML is pretty straightforward. You prepare a data set, and then you choose a target. So the target is you saying, when I'm done with this model, where am I going to deploy it for use? Am I going to deploy it on the cloud, or am I going to deploy it to something like a mobile device, what you might call edge devices? So that's the target environment. And then you need to consider a budget. So the budget is just saying, how many hours do I want you to run this thing for? So up on the screen, we have an example of AutoML as you would find it if you went into GCP. And so what you see is that first you have to select an objective, and the objective states what it is that you're trying to do. Are you dealing with images? Are you dealing with tabular data? Are you dealing with text, or are you dealing with video? And if you're dealing with images, what are you trying to do? Is it single label classification? Is it multi-label classification? Are you able to just detect, are you trying to just detect objects within an image? Or are you trying to do segmentation? So whatever it is, you have your various options that you're able to pick out, and then you can upload your data set, and then you can send it off to training, and you don't need to sit and wait for it. So if your budget is 3 days, for example, then upload all of your data, set it off, and then you'll get an email notification when your training is done. Now, if you're a data analyst and you're wondering, typically as a data analyst, what do you work with? You work with either databases, writing SQL, or you work with visualization tools. You don't really write code. right? That's not your forte. So you need a solution that caters to the way you work. You're not going to be calling APIs because that requires writing code. That might not even leverage your data. You don't want to go with AutoML for whatever reason. You're not building mobile apps. So for data analysts, there's something called BigQuery machine learning. And all that it requires is SQL, but you still need to know the fundamentals of machine learning. You need to know what feature engineering is. You need to know what hyperparameter tuning is. You need to know what optimizers are. But once you know all that, you don't need to go write Python or R or Java or whatever language it is. You can do all of that within SQL, right? So at the end, you're even able to leverage explainable AI to understand the model and how it interprets the data, the training data that it got, how it scores the weighting of various parameters, those sorts of things. So that's BigQuery ML. And BigQuery ML supports various model types, quite a large number of them. So again, if this is your forte, you've got linear regression, you've got boosted tree regression, you've got deep neural networks for regression, you've got linear combined regressors, and you've got the same thing on the classification side. So you've got logistic regression, boosted tree classifiers, you've got things like k-means clustering, matrix factorization for recommender systems. You've got time series with ARIMA Plus. You've got principal component analysis and autoencoders for things like dimensionality reduction. And you can read up on BigQuery ML on the link shown on the screen. And then we get to TensorFlow. So, if you work directly with the code, then TensorFlow is out there. And TensorFlow is available directly. You can work with it on your system. You've got Google Colab, which will let you work for free and will even give you access to GPUs. You've got back on Google Cloud Platform, you've got AI Platform, which is the older one. And then you've got Vertex AI, which you'll see later on. You've got AI Hub, and you've got Cloud TPUs. Cloud TPUs are just application-specific integrated circuits that will speed up your training process, especially when you're dealing with very complex data like computer vision and natural language processing. And so when you get to Vertex AI, it's a newer version of the AI platform. The AI platform was previously called ML platform. And you're able to do a lot of things. When you think of the machine learning pipeline, there's so much that you can do on Vertex AI. Things from data readiness and feature engineering all the way to training, deployment, and model management. You're able to work at various levels. So you can see at the very top, you've got AutoML and the various model types that it supports. Below it, you see things like data labeling, feature store, continuous monitoring, experimentation, explainable AI. They're all there, AI accelerators. We've got pipelines for orchestration. And then way below that, you've got a deep learning environment. So you've got virtual machines for deep learning and containers, and you've got notebooks as well. So this is a view of the menu if you're on GCP and you scroll down to the Vertex AI section. So you see that you've got a dashboard, but then you've got various options. Apologies. You've got various options for, again, things like data sets, features, notebooks, pipelines, models, all sorts of things that you can do in terms of training and deploying machine learning models, as well as experimentation, of course. So Vertex AI utilizes a pipeline-based workflow. And so the question will be, why do you need pipelines? How do you chain components, and how do you integrate other GCP services? Now, there are basically two options for writing pipelines. And at this point, I should also mention that pipelines aren't for everybody, right? Even though when you think about machine learning, it's a pipeline. But sometimes if you are just starting out or prototyping, or you're doing something small, then you don't actually need pipelines. But when you get to the scale where things start to break, think of pipelines the way you would think of, say, Kubernetes, right? At the very beginning, you might not need Docker containers. Even when you need Docker containers, you might not need container orchestration. You might not need Kubernetes. You might just be fine with something like Cloud Run. But when you get to the point where you need Kubernetes, then you know that you need it. It's the same thing with pipelines. When you get to that scale as a startup or as a company where you need pipelines, then you know that you do. And at that point, with Vertex AI, you have two options. You can work with Kubeflow pipelines, or you can work with TensorFlow extended. Now, whichever option you take, just know that with Vertex AI, it's easy to scale up and scale down. You've got data version control that comes in. So what that means is if you're managing your data sets, you're able to even know which version of the data set you used to train which version of the model. That helps with tracking things like data drift. And data drift is, where things have a certain property early, maybe at a point in time, maybe like early in the year, but then later in the year, those properties start to change. And those properties are usually statistical properties, right? So measures of central tendency and measures of deviation. AI platform is able to handle model version control. It's able to monitor model prediction. So it tells when your prediction starts to go off, your prediction quality starts to go off, which again is a function of drift, right? And then there's an endpoint that you can also use to manage these things. And then you can even build your own app to consume model prediction with other GCP products. So you can build that into App Engine, Cloud Function, Cloud Run, whatever it is. Once you've trained your models and deployed them, you have API endpoints that you can call to consume all of this. So thank you for sitting through this presentation. Enjoy the rest of your day.